Listen up, Derek's going to explain what he did. Derek, go ahead.
So, first I found the mean from the problem.
Uh-huh.
It's 17.2. I found the standard deviation also written in there, which is 2.5. And then find the
Sigma X bar? That one?
X bar means it's the same as the gradient, so I say 17.2. And then the standard deviation, you do 2.5 divided by the square root of 55.
Good.
And you get 0.34.
Great.
And then you find the z-scores for 17 and 18. The first one, 17 minus 17.2, divided by the
New standard deviation? Yeah.
the new standard deviation, you get negative 0.59. Then you do the same thing for 18, 18 minus 17.2, divided by the new standard deviation is 0.34. You get 2.35, and then you draw the little
Curve, yep. Great. Perfect. So a couple things to note. Remember, if your number, here I gave you two numbers, and you need to find the area between them, right? Between 17 pounds and 18 pounds. So you need to find the z-scores for each of them. 17 and 18. Remember, if it's below the mean, it should be negative. Because people always want to do 17.2, they want to take the larger one minus the smaller one. So remember that if it's below the mean, it should be a negative number. If it's above the mean, it should then be a positive number.
It's 2.37.
So
Oh, it could be.
test-wise,
Okay, so if you round it slightly differently, you have 2.37. That's fine.
Okay. On the test, it'll be.
Yeah. Yeah. So you probably got at least like.
0.71.
But what'd you get here?
0.7. Because we didn't round the 0.34, we did 0.337.
Yeah.
0.337.
Okay. But this can't be. This is not going to be 0.7.
That would be.
That's what I
Oh, it
got.
might be 0.7.
Yeah.
Oh yeah, I think you
We just did
You put-
0.337 in the beginning. We didn't.
I think you did something strange.
0.9.
Oh, I know it. You didn't. You did 0.59, not 0.0 negative. I think you forgot to put the negative in your calculator. You wrote it, but you didn't write it.
Even
No,
with
no.
the negative, you get it. Oh.
If you did positive, you wouldn't trigger.
So negative.
Yeah,
bro,
so I think
that's wrong.
we would have calculated it to just that's got to be because it should be larger than.
Yeah, it should be 0.713.
Okay, 0.713 or 4 or 5 or 0.7 points. So if you're at like 0.705 to 0.72, you're still within 1%. It's really close. You know what I'm saying? So as long as whatever you did here matches up with whatever you got there, then you're fine. And you guys see how he showed his work, but then got the wrong answer because he mistyped something in his calculator? If you do this, you're only going to lose half a point. If you didn't do this, and he just gave you that other thing, the 0.3, then you're going to lose a ton of points. You see what I'm saying?
Yeah.
But if I can track and say, oh yeah, that's right, oh yeah, that's right, oh yeah, that's right, oh, there must have been a typo somewhere, half point. Does that make you guys following?
Yeah.
Yeah. So maybe 1 point, depending upon where I think, depending on how complicated it is, but somewhere in that range, you're going to lose very little, half a point or a point. Okay, great. Thank you. Now, very quickly, I need to discuss with you guys the normal approximation to the binomial. We'll have, Felicia, do you want to go and read for me?
Sure. The normal approximation to the binomial distribution. So, normal distribution is often used to solve problems that involve the binomial distribution. Since when n is large, say 100, the calculations are too difficult to do by hand using the binomial distribution.
Right. So, for example, if you wanted to know, you flip a coin 300 times, you want to know the probability of having 200 or more heads. you don't want to find the probability of 200, 201, 202, 203, 204, and add those all up, right, to 300. That's a lot. So instead, when n is really big, very often it looks sort of like, it looks kind of normal. It looks sort of like a normal distribution. Does it always? No. Here's the thing. If you look at the first one, that's not very normal. It's kind of scrunched up over here. It kind of jumps out over there. That's not very normal. This one is quite normal. Do you guys kind of see this one? Right? So here, when n is 15 and p is 0.2, you get something like this. And here, when n is 20 and p would be 0.5, you'll get this nice looking one. What you do is, when np is greater than or equal to 5, and nq is at least 5. When np and nq are both at least 5, then you're good. And that means your n is big enough for it to look pretty normal. Over here, what's n times p? 15 times 0.2 is only 3, so that's why this doesn't, you can see it, that one doesn't look normal enough to approximate. All right. So here's the deal with it. Binomial. What are the issues? What are the things? How do you know something's binomial?
It only has 2 outcomes.
It only has 2 possible outcomes. Right? So something happening over and over again, where that thing that's happening over and over again only has 2 outcomes. What else? Set number of trials. So the thing we're looking at, we're doing over and over again, we know where we're going to stop. It's a fixed number of times. We're going to draw so many marbles, or we're going to roll so many dice, or flip so many coins, or survey so many people. The other thing is that all the probabilities have to remain the same for each draw, or for each trial. Right? Little p has to stay the same. So binomial has 2 things that are fixed with it. What are those 2 things for any binomial distribution?
Fixed number of trials.
So yeah, fixed number of how many trials?
2.
N. So n is one thing that's fixed. What's the other thing that's fixed, that doesn't change? The probability, the little p. The little p. The probability of success for one tiny trial. For just one trial. Not the whole probability, just that one trial. So little p and n, np. That determines your probability distribution. So then what's the other thing? What's the thing that varies with probability? With binomial. I think it varies with binomial distribution. N and p are fixed. What's the other thing I have? X. Yep. She's giving me a little x. That's the thing that varies. That's my variable. What's x stand for? Talk to your neighbors for 15 seconds. What does x stand for?
Oh, yeah.
X represents the sample size. Sorry? What value?
Just a number.
Amanda, what's X stand for?
The number of successes.
The number of successes in n trials. So I flip this coin 20 times, but X stands for the probability, the number of successes I want to get out of that 20. Okay, so that's the thing that varies. So X is my variable. Is my variable discrete or continuous? Discrete. Why is it discrete? Why it's discrete. Why is it discrete? Talk to your neighbors. Why is it discrete?
It's counting.
I want to hear what Carl said. Carl, what'd you say?
Well,
You guys, shh.
depends
Carl, good.
on your sample size. It's like you're going to flip the coin like 25 times, just throw a number out there. It's not like you're going to flip it another 26 times as you're going to stop at 25. So that's why I think it's discrete, because you're not going to keep going.
And so there's a finite number of options.
Yeah.
In other words, I can only have 0, 1, 2, 3, 4, 5, 6 successes. I can't have 1.4 successes, or 1.7 successes, or 1.8 successes, or 1.88 successes, or 1.837 successes. You see what I'm saying? Continuous, between 2 and 5, I could have 2.1 inches, 2.11 inches, 2.11 inches, 2.1111 inches, right? There's an infinite number of values between 2 inches and 4 inches. That's what makes it continuous. Discrete means that if I pick two numbers between 0 and 6, there's only a fixed number of options between there. I could have 1 success, 2, 3, 4, or 5 till I get to 6. I can't have an infinite number of possibilities between those two. But continuous, between 0 and 6, there's an infinite number of inches that you can be between 0 and 6. And you can, like I said, 0.1, 0.11, 0.111, right? We talked about that before. So binomial is discrete. Normal distributions are continuous. So here's the deal. We're taking something what's discrete and we're forcing it to be continuous. So we have to sort of change it into continuous verbiage, which means that if I have something that's 8 successes, 8 successes really means, so here I'm 8. What's the number to my left? 7. What's the number to my right?
9.
So there's 7 successes, 8 successes, 9 successes. So what's the boundary between me and 7? Boundary. Here's my space, here's your space, here's the boundary between them. 7.5. What's the boundary on this side? 8.5. So 7.5 to 8.5, that's me. So in discrete world, I'm just 8. But in continuous world, 8 really means from 7.5 to 8.5. Do you guys see what I'm saying? Because that's its boundaries. If you're only going by whole numbers, then 8 really is. If you measure, if you have a ruler, remember we did this before. If you have a ruler that only goes in whole centimeters, then 8 centimeters really means anything from 7.5 to 8.5 centimeters. You're just going to round to 8. So here we have to remember that 8 really means from 7.5 to 8.5. So if I want to find the probability of someone having 8 successes, then using the normal distribution, I would find the area from 7.5 to 8.5. So that's kind of what we would do with that. Here's an example. Jocelyn, go ahead and read.
Example, reading while driving. The magazine reported that 6% of the American drivers read the newspaper while driving.
Great. So this is good prep for your exam. What kind of distribution is this and how can you tell? 15 seconds with your neighbors. Take a look. What kind of distribution is this? Talk.
This is an example. This is discrete. Yes.
I'm going to give you guys actually a better way than I gave my other class.
Okay.
So what's the question that you're the researcher? What question are you asking the people in your sample? Not what am I asking you, but what is the researcher asking their people?
Do you drive?
Do you drive? Do you drive while? Do you read the newspaper while driving? Yes. Do you read the newspaper while driving? Do you read the newspaper while driving?
No.
Do you read the newspaper while driving? What kind of answers am I getting?
Yes or no?
Yes and no's. Now, here's a different kind of question that you can ask, which is a different distribution. How tall are you? How tall are you?
89 inches.
How tall are you? Great, that's fine. How tall are you?
100.
Great, how tall are you? What kind of answers are those?
Continuous.
Yeah, but,
Measurable.
Measurable. Measurable.
right, so let me break it down. Is it qualitative or quantitative?
Quantitative.
Quantitative, they're numbers. If you get quantitative data,
Quantitative data.
then you're looking at means.
Mean.
And you're looking at normal distributions. You see what I'm saying? Your data is numbers, means. If you're getting qualitative data, especially yes-no data, then either is or isn't, then you're thinking binomial. Because it's only two possibilities. It either is or it isn't. Yes or no. So here, because my question is, I'm getting yes-no answers, we're talking about proportions, we're looking at binomial. Yes, is or isn't. Does everyone understand what I'm saying?
Yeah.
Either you are or you aren't. So that means that over and over again I'm doing this trial to either say success or failure, right? That's my thing. And like someone pointed out, success doesn't necessarily mean a good thing. Like a success could be if you're interested, it's whatever you're interested in finding out. If I want to know, how many people die from the coronavirus, then a success would be dying from the coronavirus, which none of us considers to be successful, right? But that would be, but if that's what we're concerned about, then that would be our success. And so here, it's binomial, which means I need to know, what are the two things I need to know for any binomial distribution? N and P, little p, N and little p. So what are my N and little p? Everybody find N and little p.
Little piece. 0.6.
And then find my X also. So what's my N, guys? 300. 300 drivers are selected. It's a number, it's who's selected, right? Sample size. Okay? What's my little p?
0.06.
0.6%, 0.06. Okay, and what do I want to find the probability of? What's my X? Yeah, at least 25. So it needs to be, X is 25 or more, right? So it's, oh, I should redo that. Oops, my bad. X is greater than or equal to 25. So here, I need to figure out what's going on with X. And remember, when X is 25, 25 is really from what to what? In 25 in discrete world is really what in continuous world? 25 and a half on this side and 24 and a half on this side. Yeah, 24 and a half on this side, 25 and a half on this side. So you guys remember that part? Okay, so actually I think I have slides that will walk us through this a little bit better. So first, a couple things. Make sure that you can use an approximation at all. So find NP and find NQ and make sure they're both more than 5. NP is 18, NQ is way more than 5, so we can use it. Good. Now find the mean and standard deviation. Remember, I love the binomial distribution because the mean and standard deviation are really easy to find. The mean is just NP. The standard deviation is just square root of NP cubed. So find those two. So we did. NP is 18, that's my mean. My square root of NPQ is 4.11, so that's my standard deviation. Now, we want to find the probability X is greater than or equal to 25. But really, what that means is does that include 25 or not include 25? At least 25. Does that include 25?
Yes.
Great. So that means that I need to include 24.5 to 25.5, which means if I'm going greater, it's going to be 24.5 and greater. So that's why we have, it really changes it to the probability that X is greater than 24.5. Then find the z-score for that. 24.5 minus the mean divided by the standard deviation, 1.56. So it'll be like that. Here's my here's the 1.58, sorry, 1.58. And I want greater than or less than? So I'm going to shade to the right or the left.
Right.
Right. Good. And then we're going to do normal CDF of 1.58 to 999, and we'll get, this is their approximation. You do not need to know how to do this. I have to cover it. Because the reason why you don't have to do this is because of this. CI 83 and 84 calculators can do this now. Back in my day, we had to use this. Your day, things are much easier. You guys got it easy. No, just kidding. You have other issues to deal with. So here, your calculator can do this. If I do second vars and go down to binom CDF cumulative, I can put in my n, comma, p, comma, well, what I want to go up to. So my n is 300, my p is 0.43, and it gives me up to a number. So if I want 25 and above, then I really need to find up to 24 and subtract from 1. So I'll do that. 24. And oops, I did something wrong. Oh, I know. I used 0.43. Second vars is 3. It was 6%, right?
Yeah.
300.06. Try that. Comma 24. And then we get the area below is 0.9377. So that means that I could do 1 minus binom CDF of 300, comma 0.06, comma 24, and I'd get 1 minus 0.9378, which is 0.0622, which is pretty close, right? If you look at these two, they're not that far off. I mean, they both are around to 6%, right? They're off a little bit. They're off like 0.5%. That's because this is an approximation, and this is the actual number. Again, you don't need to know any of this for the exam. You will not get any homework on it. You will not get tested on it. But I wanted to cover it, this normal approximation to the binomial, because we have to. It's in our CID. So we are required to cover it. You can now promptly forget that if you like. It's all good. I do want to point out one thing, though. You can use binom PDF, not CDF, PDF, to find the binomial distribution for a specific x. However, I'm still going to force you to write down the formulas. Anyways, so you can use it to double check or whatever. But say, for example, n is 8, little p is 0.43, and I want to find the probability that x is 5. Then you should do this, right? You would do 8 choose 5, n choose x, times little p, 0.43 to the x to the 5th, times little q. If 43% is my success rate, then my fail rate must be 57. In other words, if I spend 43 cents and give them $1, I should get 57 cents change. That's how you kind of find that easier. And then, if I have 5 successes out of 8, how many failures do I have to have? 3 to the 3rd. So you have to write this out. And you can either find this on your calculator, which is not hard, or you can just do binom PDF of that. I'll show you what I mean. So here, we want 8, choose 5. So 8, again, just to refresh you, math, probability, choose, NCR right there, hit enter. And I want, so you have to put the 8 first, and then the NCR 5, enter to get your number. and then times 0.43 to the fifth, times 0.57 to the third, and you'll get, that's your probability. You could have just done second bars down to binom PDF and put in n 8 comma little p 0.43 comma x 5, and I'll give you the exact same thing. So these two numbers, you get the same number either way.
What was that bottom one?
I'm sorry?
The bottom one, what did it say? What you just did?
Binom PDF?
Okay, yeah.
Yeah. But you still have to show me the formula. You still have to give me the 8 choose 5 times 0.43 to the fifth times 0.57 to the third. You have to prove to me you know where those numbers go in that formula. If you don't, if you do not show your work, you will only get potentially half credit on each problem. And I need to know where you got these things from. I need pictures. I need other stuff. Right? So, okay. I think now's a good time for a break. Let's take a break.